Hi, today we're going to have our last lesson in Chapter 3. Topic will be equations of lines. Before we can talk about lines, though, and their equations, we need to just refresh your memory a little bit about slope. So I'd ask you to think about what you've learned in your algebra classes previously. I would almost guarantee that you've had a teacher who told you that slope was rise over run, which makes pretty good sense. Since it's the y values of points that have to do with the rise of things, you may remember hearing that slope is the change in y divided by the change in x. Run has to do with x values because that's the across. And at some point in your algebra career, you would have learned a formula for slope. That is, it's the difference of the two y values, or of the y values of 2 points on your line or segment, divided by the difference in the two x values. I'd like to have you take a second right now and look at this little example from your book. These are pictures of ski slopes. We have some dimensions for them, and we are supposed to decide which is the most difficult, which is the intermediate range, and which is the easiest slope to ski down. Will you stop your video right now and find that out for me, please? Here are my calculations. The A was rise, that is the up and down over run, came out to be a ratio of 0.36. The B run, 1180 divided by 3000, came out to be 0.39, and the C run, this one, the easiest one I would say because the slope is 0.33. Most difficult would be the B run, and that was just to get us remembering a little bit about slope, rise over run. I want us just again to collect a little bit of fact here. There are 4 different types of slope. A positive slope, so if you do the slope calculation and get a positive number, that means that you have an increasing line. In order to get a decreasing line, such as this one, that's a negative slope. So when you do the arithmetic for finding slope, you'll come out with something negative. These are the two that are easiest to get mixed up. A horizontal line, one that goes across, has a slope of 0, and a vertical line up and down has no slope, and that's because there is no run to this, there's only rise. On this one, there's no rise, only run. That's a slope of 0. But when we get a vertical line, no slope possible, or many people will say undefined slope. I want you to be very careful. If it's a horizontal line, the slope is 0. Not none, but 0. And then I would like you to stop again the video and use the formula that we have up here for slope, remembering that this point has its own x and y, and this point has its own x and y. Very good. You can see my calculation there. I subtracted the two y values, -2 minus 4, and the two x values. Came out with -6 divided by -1, a positive slope of 6. Very good. Next, we want to talk a little bit about the equations of lines. And again, this is information that you have previously from your algebra class. The slope-intercept form of a linear equation is one that follows this pattern: y equals mx plus b. In that pattern, m equals the slope. That's the variable we usually use for slope. B is the y-intercept of the line, or where it crosses the y-axis. Our first activity here asks us to write an equation for the line whose intercept is -2 and whose slope is 3/5. Folks, I think they gave you both things that you need. So an equation for that line would just be plugging in what they told you. Slope of 3/5, that goes with the x, and then an intercept of -2, and I'm going to write plus -2, but you know that you could certainly write just -2. And that is really wonderful if they give us the slope and y-intercept, although that's not often what happens. Okay, I'd like to introduce you to the point slope form of a linear equation, which is a handy way for finding the equation of a line if you know a point on the line and the slope, or if you know 2 points on the line, because then you can find the slope. Okay? The format for point slope form is this: y minus y1, and y1 comes from a point, y is part of the guts of this formula, is equal to slope times x minus x1. Again, x1 comes from the point, x is part of the deal, just like plain old y, m is the slope. Here, our next activity asks us to write an equation in point slope form for the line that goes through these 2 points. In order for us to do that, we're going to have to find a slope and then use the slope and the coordinates of one of the points. I'm going to ask you to stop the video and do that for me now. There are 2 possibilities. You could have used either point. For my equation on the left, I used the left point, y minus the y of the point, so y minus a -1 is equal to slope -5 times x minus a -2. Now, many of us would have further simplified, so that looked like this: y plus 1 equals -5 times x plus 2, and that's fine as well. If you use the second point, as I did here, the final result would be y plus 6 equals -5 times x plus 1. Both of those are okay. Those are both the equations in point slope form for what we're given, and you'll notice that we came up with 2 things that look different. They have the same value, folks. They have to, because we're talking about the same line. So if you did the distribution, multiplied it out, and simplified, you would find that those 2 are identical. I'd like us to now move on a little further and talk about slope and geometry. What we're going to say here is if 2 lines are parallel, that means that they have the same steepness, if you will. They're running the same direction, and that means that their slopes have to be the same. Right? If you're going to be running the same direction, you got to have the same slope. We have a practice problem that tells us that there is a line which contains the points A and B, a second line which contains C and D. Our job is to find if those 2 lines are parallel. What you will have to do here is find the slope for each line and then compare them. So will you stop the video and do that for me, please? You can see my results here. The slope on the first line I found by subtracting y's and then divided by the subtracted x's. Reducing puts it into this format, -1/3. The second line had slope +1/3. Folks, those cannot be parallel because the slopes are not exactly the same. In fact, even though the number parts are the same, the signs are different. So line 3 here would be a decreasing line. Line 4 would be an increasing. They're not parallel. Now we want to kick it up a notch, as is often the case. In this activity, you're going to be asked to write the equation of a line that's parallel to this line, but which goes through the point 5, 9. And our job, it says, is to put the equation in slope-intercept form. Well, folks, if we are going to be parallel to this line, then we need to have the same slope. So if you would pick the slope out of this line, it's either 5 or -9. Which is it? It's the one with x. The slope is going to be 5. If we want to be parallel, that's the slope we have to use. And now we have a point, x1, y1, that we can use with point slope form to get started. And that pattern again is y minus y1 equals slope times x minus x1. So let's see, y minus the y, which is 9, y from this point, equals slope times x minus the x from the point, which is 5. That's the point slope form equation. However, this asks us to put it in slope-intercept form, so we have to do the arithmetic here to get y by itself. I'm going to distribute on the other side. 5 times x. 5 times 5 is 25, and there was a minus sign in there. Now to get y by itself, we must add 9 to both sides. And our equation is y equals 5x minus 16. Negative 25 plus 9 is negative 16. Folks, we know we're parallel because we have exactly the same slope. Good job. The last of our concepts for today talks about the slopes of perpendicular lines. And when two lines are perpendicular, you learned in your algebra class that their product of their slopes, when you multiply their slopes together, you will get negative 1. Another way to say this is the slopes of perpendicular lines are negative reciprocals. Negative reciprocals. So if you think about that, the negative reciprocal of negative 1/2, well, it has to have the opposite sign, which would be positive, and you flip the fraction over. So negative 1/2 and 2/1 are a pair of negative reciprocals. What if we said 3/4? What's the negative reciprocal of that? Sure enough, change the sign, so it's going to be negative. Flip it upside down, 4/3. Those two are negative reciprocals. Now, as you look at the picture that we have here, we're asked to judge whether those lines are perpendicular. That is, do they make a right angle? Certainly looks like it, but you can prove it by looking at their slopes. So I'm going to find the slope of the increasing line, and since I have a picture, I'm going to look for two places where that line crosses through grid marks, and then I'm going to follow from the lower point to the higher. I have to go up 1 while I go over 2. That line has a slope of 1/2. Up 1, because rise goes on top, over 2. That's the run. I do the same thing for this line. Find two places where that line crosses through a grid mark. Then I want to think, how far up do I have to go? I got to go up 2 while I go back 1. So in this case, up 2, left 1. The question is, are these lines perpendicular? Yes. Okay. Their slopes are negative reciprocals. All right, I know this is bringing back memories for you because I'm pretty sure you've done this before. Our last activity of the day asks us to write the equation of a line perpendicular to this line, which passes through this point. I'm going to put an x1, y1 there because I know that's the point I got to deal with. I need to know the slope of this line, and a good way to find the slope is to solve this equation for y. So I would ask you to work along with me as I do that. First off, I want to subtract 6x from both sides, and that's going to leave me this, minus 3y equaling minus 6x plus 24. Then I divide by negative 3, which is going to leave me with this, y equals 2x minus 8. What I care about in this line is its slope. The slope of that line that was given to us is 2, so the slope of the new line is going to be negative 1/2. Now we're good to go. Point slope form, y minus y1 equals slope times x minus x1, and filling in y minus the y in our point, which was negative 5, equals the slope of our line, negative 1/2, right? We want to be perpendicular to the given line, so we use the opposite reciprocal slope. Then it's x minus and the x from the point, negative 10. We are to put it in slope-intercept form, so we do have to do a little bit of work here. I'm going to come up here. Y plus 5 equals negative 1/2 times x plus 10. We need to distribute and then subtract 5. Okay, we need to distribute first, so negative 1/2 times x Negative 1/2 times 10 is negative 5. We need to subtract 5 from both sides. And our final result, y equals negative 1/2 x minus 10. That's our equation in slope-intercept form, and that puts us perpendicular to the given line. I need you tonight to get out there and do the U-try, and we'll talk about this in school tomorrow.